Hello, welcome back. We're going to be working with thermodynamic data from tables and charts. Very important table is the water table, the steam table for water system. This is the table, and this table is going to be stating saturated water. This is with the basis of temperature. We have one of them, the one that has pressure, which is exactly the same information. Here you have the saturation pressure, and here you have specific volume, internal energy, enthalpy, and entropy. This is VF is the information for the saturated liquid, BG is the saturated vapor, and this is in cubic meters per kilogram. You also have a table in the English system. For the internal energy, enthalpy is kilojoule per kilogram. Here you have the saturated liquid, the saturated vapor, and the difference between these two is this UFG. The same with enthalpy, the same with entropy in kilojoule per kilogram Kelvin. Now, very important, in the temperature, you will have one pressure, which is the saturation pressure or the vapor pressure at this given temperature. And here is the volume of saturated liquid and the volume of saturated vapor. This is a range, right? The HFG is the amount of energy in order to vaporize the liquid from liquid to gas. And this is what we called previously the latent heat of vaporization. This is HFG. It's the same for this table. Now, the situation here is that sometimes you will have a value in the middle between these two. So this can be measured by the quality. The proportion of liquid and vapor phases in the mixture is called this quality. It's the amount of vapor, mass of vapor per total mass, which is equal to mg over mf plus mg, being f the liquid, g is the part that is going to be in vapor. And this has a meaning in this saturation region, not in other region, and has a range from 0 being 0 totally liquid to 1 being 1 totally vapor. If it is in a range, then this is a mixture of these two. Any given property in the saturation region may be determined by the quality. We're talking about the quality, the properties that are extensive properties, or in this case, since they are per unit kilogram, they are specific properties. Of course, these two are not going to vary with the quality, they are going to remain constant, but all of the next ones are going to vary such that the property P, the property can be V, can be the volume, can be the enthalpy, is going to be equal to the property of the liquid plus the quality times the property in this, the difference in between vapor and liquid, Fg. So in a given example, if I give you 3 kilopascals, here are 3 kilopascals with a volume of 5 cubic meter per kilogram, then the temperature is direct 24.008. I know that this guy is in the saturation region because it is between these two values. If it is this value, then it is saturated liquid. If it is this value, then it is saturated vapor. But since it is in these two values, then I can generate the quality, being the quality, the property by itself, 5 minus Vf over Vg minus Vf. And this gives me 0.1095, which means that 10.95% is in vapor. The rest is going to be liquid. So with this, I can generate, or I can get the enthalpy HF plus XHFG. Actually, this guy is exactly the same formula, but solved for quality. So I get 100.98 plus these values, right, from this table, and I get an enthalpy of 368.587 kilojoules per kilogram. If it is not a saturated vapor, but the vapor is higher than any of these values, then I am talking about a superheated water, and this is this table where you have pressure, you have the saturation point. Here in parentheses, you have the saturation temperature. Here you have the saturation properties, and the rest is going to be for more temperatures, 50, 100, 150, etc., etc., etc. So you can directly read these properties of volume of enthalpy in any given case. And this provides the overheated region. When you begin working with properties, the best is to suspect that the fluid is in the saturation region, and you can prove that the fluid is not saturated and otherwise is overheated. If the quality is larger than 1, then that doesn't mean anything, and you cannot use table A4 and A5. The pressure at a given temperature is lower than the saturation pressure. The temperature at the given pressure is higher than the saturation pressure, or any specific property reported is higher than the saturated vapor. We are also reporting certain properties in charts. This is the chart that is for the air-water system. This is the psychrometric chart. Here you have the dry bulb temperature, which is the temperature that you measure directly. And in any given case, you will have these lines that are going to be the relative humidity. And you can read, let's say from here, you go 30 and 10%. You can read the moisture content, which is the kilograms of water per kilograms of dry air. You can also read the saturation temperature. If you go in a line like this, from that point where you will read the wet bulb temperature, and you can also read the enthalpy at the saturation. But the enthalpy has these lines, so you have to take into account that there are lines where you have the enthalpy deviation in kilograms per kilogram of dry air, kilojoule per kilogram of dry air. So you have to add or subtract what it says in these lines to this enthalpy that you're going to be reading. So these are the tables and charts that we're going to be using during some exercises. So thank you very much.